We're going to solve problems using combination and calculate some permutation. So combination and permutation, when you select some element out of total given element and form some group out of selected element for permutation, or you can trying to find out how many groups you can form from the given total elements. Okay, so before we start solving problem, I want to real quick put the formula there. Combination is equal this is our n is equal n factorial over n minus r factorial times r factorial. And probability, selecting r out of this n, is equal n factorial n minus r factorial. So real quick, let's understand what factorial is. Let's say I have factorial of 8. That's mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't have to open, so multiplication of numbers, of the sequence of numbers from 8 to 1. Now, I don't have to open every time all the way to 1. What if I have factorial 200? I mean, somebody will call 911 if I start writing all these numbers till 1. So you can write down in the following form. Let's say 8 factorial. It's enough for you, and you will see in the problem when I use these examples. Let's say I am opening till 5, and 5 I put factorial. Anytime you need, you can open 5 also. But you don't have to go all the way. You can stop somewhere that is good enough for you. All right, so let's solve the problem here. There are 25 people on the stadium to play team game. In how many different ways can 8 people form a team for the game? So what do we have here? We have n is equal 25. And we have r, selected people, is 8. Now, is the order important? Which one you will choose out of 8? Which one you will choose first? No, of course it's not important. Therefore, we are using combination. So combination 25 and 8, meaning 8 out of 25, and here is your formula. I open so you can see. It's gonna be equal 25 factorial and then 25 minus 8 factorial times r factorial. So see, 8 out of 25 is gonna be equal, see, I put this one first, 25 minus 8, 17, because now I will open 25 only till 17. I don't need further, because so I can cancel. And factorial, oh, here I just left r instead of plugging numbers, 8. So in here I will have 8 factorials. I can open 8 times 7 times 6 times 5 times 4, 3, 2, 1. I don't have to put 1, I just put 1 so you can see we are going all the way from 8 to 1. And 25 I will open till 17. 25 times 24 times 23, 22, 21. This is multiplication. 20, 19, 18, 17. Well, I have enough writing these numbers. Okay, so canceling here. 17 with 17, that's number 1. Then what do we have? 8, yes, with 24. This is 1, this is 3. What else we have? 7, yes, this is 1, this is 3. 6, let me bring more down. Okay, 6. Do we have anything yes, 6 and 18, it's gonna be 3. And then 5, it's gonna go with 25. 4, it's gonna go with 20, it's gonna be 5. 3, I can cancel this 3 with this 3. Yes. And then 2 I can cancel with 22, which will be 11. Well, and 1. So let's see what we have left. No, that's not what I wanted to do. Well, yeah, it's moving. Okay, that's what I will do. Nice. Okay, so making space. So we have C, 8 out of 25. It's going to be equal, since at the bottom I don't have anything left. 5 times 3 times 23 times 11 times 5 times 19 times 3. Okay, let's do the math. I hope I didn't leave out any number. 5, 3, 23, 11, 5, 19, 3. Okay, let me see what we get. 15 times 23 times 11 times 5 times 19 times 3. And we get 1,081,000. This is 81,000. 5. Okay, let me write nicely. It's my handwriting, sorry. 1,081,575. There we go. So look how many combinations we can get, how many groups out of consist of 8 people we can make out of 25 people. It's enormous, right? Okay. 1,081,575 groups I can that consist of 8 people I can create from 25 total people. Okay. Next one. An environmental agency is analyzing water samples from 50 lakes for pollution. 9 of them have dangerously high level of dioxin. 5 lakes are randomly selected from the sample. How many ways could 2 polluted lakes and 3 non-polluted lakes be chosen? Okay, so we have what? Total 9 have been dangerously dioxined, and out of them 2 lakes are polluted. So what do we have here? We are going to get first how many legs, how many the combination we can get out of polluted lakes, 2 polluted lakes. So n is equal 9, r is equal 2. So combination 2 out of 9 is equal 9 factorial over 9 minus 2 factorial and 2 factorial, which is equal 9. Since I have here 7, so I'm going to open till 7. Nice. And times 2 times 1. So 7 and 7 is gone. And 8 and 2, this is 1, this is 4. 9 times 4 is 36. 36 combinations I can grade out of 9 total elements. And this combination consists of 2 people each. So this is first, we are heading towards answering question, how many ways could 2 polluted lakes and 3 non-polluted lakes be chosen? So first we are taking care of how many ways could 2 polluted lakes. This one we are going to take care of now. We just did 36. Okay. Be chosen. Okay, we have 36. Now we need to figure out how many ways 3 non-polluted lakes be chosen, and then multiply by each other. Okay, so this is first part we just solved, and we are moving to second part now. 3 non-polluted lakes. So what do we have? Out of how many lakes are not polluted? So if we total checking 50, right? And 9 of them are polluted. So how many are not polluted? So n is going to be equal, because our 3 lakes are non-polluted and we are trying to find combination of non-polluted. So total we have 50. And we know that 9 of them is polluted. So 41 is not non-polluted. Our n is going to be 41. Our r, guess how much is going to be? Yes, of course, it's going to be 3. So combination 3 out of 41, and because order is not important, so we are using combination. So we have 41 factorial over 41 minus 3 and times 3 factorial. Okay, let's solve it. So 41 3 out of 41 is equal 41. So at the bottom I have 41 minus 3, 38. So 41 I'm going to open all till 38. 41, 40, 39, 38. And 3 factorial is 3 times 2 times 1. So 38 is gone. 3 I can cancel with 31. It will be 13. And 2 I can cancel with 40, 20. And that's a result. Please multiply for me. 41 times 20 times 13. So 41 times 20 times 13. It's going to be 10,660. Yes, you are correct. So 10,660 combinations we can create out of 41 based on free elements as a selection. All right, so we got combination for polluted lakes, and we got combination for non-polluted lakes. So now to figure out total, because it says here total, and remember when we have and we multiply by each other. So what I'm going to do, take 36 multiply by 10,660, and the answer is going to be 383,760, and this is going to be our answer. Next problem. It is recommended to consume 2,000 calories on a daily basis. One meal is considered one main dish, one breakfast, and 2 different desserts. If there are choices of 4 main dishes, 5 breakfasts, and 8 desserts, how many different meals are possible? So, four main dishes and then 5 breakfasts, 8 desserts. So let's see how many we can choose from how many. So out of these 4 main dishes, we can choose 1 main dish only. So 1 out of 4. Next, 5 out of 4, the 5 choices for breakfast, we can choose 1 breakfast. And out of the 8 choices for dessert, we can make, thank God, at least 2 desserts we can have. Chocolate and ice cream. How about you? Okay, so from here, we are going to find out how many different meals are possible. Is order important? I'm not talking about eating. Of course, eating is important. You won't eat chocolate first and then turn dinner. But as to me, when it comes to chocolate, it doesn't matter to me when I will eat chocolate. But as to when you choose, it doesn't matter, right? You the order you say about make your choice about dessert or make your choice about main dish first. It doesn't matter. So at this point, we are going to use combination. Okay, if it does matter order, then we would use the permutation. All right. So first one, you are going to solve for combination 1 out of 4. We are choosing 1 dish out of suggested 4 choices of dish. This is going to be 4 factorial, 4 minus 1 factorial, and times 1 factorial. Well, I can drop 1 factorial because it doesn't do anything. So 4 minus 1 is 3 factorials. So I'm putting 4 times 3 factorials. This is gone and I have 4. Okay, combination of 4. So I'm choosing 1 out of 4, so 4 of them. Next, combination of one breakfast out of total 5. Now I'll open little secret. Every time when you choose 1 out of whatever number, result is going to be that number. So I'm going to put 5. If I would have one of the combination of 1 out of 10 would be 10. So that's only when you choose 1. Now different story is going to be with dessert. Since we have 2 desserts out of 8, this is going to be, so 8 factorial, 8 minus 2 factorial and times 2 factorial. So which means 8 minus 2 is 6 factorial, and 8 I'm opening till 6. And 2, just leave 2. It makes no sense to put times 1. So 6 and 6 is gone. 2 I can cancel with 8. So the answer is 4 times 7. It's going to be 28. All right. So from here, we got all these choices. So total, how many meals, the different meals are possible. So let me see. 4, 5, and 28. We multiply by each other. 4 times 5 and then times 28. So 28 times, oops, hold on, I was thinking 4 times 5 is 20, so I put 20. So 28 times 20, it's going to be 56, and I'm adding 0 next to it. 560 total meals you can make, you can choose out of this suggested meal, dish, breakfast, and dessert. Okay, moving to next question. Next is gonna be calculating permutation. So permutation is going to be, what was the formula of permutation? Look here. Let me go back. Here. It's like combination with the difference you don't have here is R. You don't multiply here this R, see? That's all. Alright, so we have 30 factorial divided by 30 minus 3 factorial. That's it. I don't put here 3 factorial. So since at the bottom I will have 27 factorial, so further I'm opening till 27. Factorial. This is gone with this. Alright, so let's see. We have 30 times 29 times 28. And we are getting 24,360. Again, permutation we use when order is important. When you have to choose this one, and then you have to choose this one, and then you have to choose third one. And it has to be in that order. Okay. Question number 5. The probability that randomly selected student pulls car to drive to school is 0.04. The probability that randomly selected student drives own car is 0.92. Complete the following question. Okay, let's see. So, what's the probability that randomly selected student pulls car or drives own car to drive to school? Keyword here is or. When you have or, that's mean you will find a probability that a randomly selected student will pull car, and then you have probability of that how many students will drive to school by on own car, and these two probability you need to add them up. Okay, if there will be and, then we would multiply by each other. Yes? All right. Okay, so I wrote down, prepared already, that probability that student pull the car. Here it is. Is 0.04, and I mark down as a probability of A. And the probability that student drives car, and I don't know, no clue where from on came on. Own car. Lost the letter somewhere. Okay, it's 0.92. Correct? So what's the probability that it's gonna be a student either gonna pull the car or gonna drive own car? So probability let me make thicker. A or B is equal probability of A plus probability of B. That is equal 0.04 plus 0.92. And we get 0.96. So 96% is a chance that the student pull a car or drives own car. Next one. What's the probability that randomly selected student does not drive car to school? So what was our probability that do drive car to school? It's 92, correct? So this 92, if 92 is percent is driving car, then the ones that don't drive car, it's going to be 92%, 100 minus 92, 8%, right? So the students who drive car, we mark down as a P of B, probability of B. So if probability of B, driving car, is 0.92, then probability of not driving car, we say complement. There we go. It's going to be 1 minus 0.92, and that is equal 0.08, which is 8%. Multiplied by 100, right? Decimal notation. It's 8%. Okay. Moving to next question. What's the probability that randomly selected student neither pulls car nor drives own car? So the keyword here, neither, nor. Which means it's going to be negation of pulling car or negation of owning car, or it's the same thing, is a complement of neither pulling and nor driving. All right, so that will be complement of the probability that we found that the pulling or driving, right? Where is it? Pulling or driving, it's right here. Probability of pulling or the driving, which means neither pulling nor driving, it's going to be the rest, right? Leftover, which is gonna be probability of A or B prime, prime meaning complement, it's gonna be 1 minus 0.96 is equal 0.04. Okay, this is all from week 2 homework. So look for next recording. Thank you for watching.